Hey everyone, and welcome back. In this section, we're going to be talking about string formatting. So strings have a lot of uses in Python, as y'all have seen throughout this whole quarter. We use them in file paths and file names. We use them in function arguments. We use them for formatting our figures. We even use them in print statements to tell us exactly what's happening in our code. With all of these uses, we have to figure out a way to format our strings to fit our needs. And one thing we want to avoid doing at all costs is hard coding. So for example, we have t equals 10, and then we're printing the statement, the temperature is 10 degrees C. And anytime this t changes, we would have to go in and change this print statement in order to make it accurate. Now, one way around that is to use concatenation. So we can say the temperature is plus string t, so we're just converting this t into a string, plus degrees C. And that works, but it can get really confusing with spaces, and it's hard to read with the plus signs, and it can get really even more confusing if you're trying to add in multiple variables. A better way of doing this is to use the .format function. So we have string.format. In our example here, we have the temperature is curly brackets, degrees C. What those curly brackets are just a placeholder for whatever arguments we put into our format function. In this case, it's T. So what this is doing is saying the temperature is curly brackets, degrees C, .format T. And we're just going to put whatever that T is into where the curly brackets are. So in this case, it's 10. Now, this format function can be really, really helpful if we're using multiple variables, right? So for example, we have T equals 10 and RH, or relative humidity, is equal to 52. And we're going to print temperature equals curly brackets degrees C, comma, relative humidity equals curly brackets percent. And we're going to say dot format T, comma, RH. And what that's going to do is going to put T, whatever it is, into the first curly brackets. And it's going to put RH, whatever that is, into the second curly brackets. And you can see that's exactly what it does. Temperature is 10, relative humidity is 52. Now, if for some reason you were to get those mixed up and put RH first, but you're setting it equal to temperature, you would end up with incorrect print statement. But a way to fix this is actually to use positional arguments instead of just empty placeholders. So in this case, we're going to say temperature is equal to 1 in a curly bracket, degrees C, and then relative humidity equals 0 in a curly bracket, percent. Then we're going to say dot format RH and T. And what that's saying is whatever is in the 0 position of my arguments, so in this case RH, is going to go here. And whatever's in the 1 position of my arguments, in that case T, is going to go here. And that's how to fix it if you have that sort of slightly out of order. An even better way of doing that is actually to just use keyword arguments. So here we have temperature equals curly brackets T degrees C, and relative humidity equals curly brackets RH degrees. We're going to say format RH is equal to RH and T equals T. And what this RH is our function argument, or our keyword. And it's going to say whatever RH equals into our format function, in this case RH, is going to go right here. And whatever T equals in our format function, in this case T, is going to go right here. So you can put them in that way. You can also format the outputs of your strings. So for example, we can round the output of a float, right? We have temperature equals 10.71717, and relative humidity equals 52.517985. And we could do the same code that we just had where we say T is going to go right here, RH is going to go right here, dot format, and we're going to put those keyword arguments in there. But we can also round them. So for example, we have temperature T, and then to do any kind of formatting of our output, we say colon, and to do a rounding, we say 0.2. And what that's going to say is we're going to round to 2 decimal places, and we're going to give it an F to tell it that's a float. Same thing with RH, we're going to round it to 4 decimal places, so 0.4, and this is also a float. You can see in our print statement, we have 10.72, so it's rounded to 72. This one is 52.5180, which is this one rounded to 4 decimal places. So let's talk about more of how we can actually customize those outputs. So this is the basic format of our function where we have a string, we have the function format, and then we have some input there. Now, this is the placeholder, or whatever you're actually going to be putting in there. It can be blank if your inputs are in order. So if, say, we had T and then RH, and they were in order, it can be blank. It can be an integer if you want to just use the positional arguments. And it can be a name if you're using the keyword arguments. So in this case, I'm using an integer because it's just the thing in the 0 position here. This is the number of characters to output. So it's going to put out 6 characters. And this is the number of decimal places to round to. Now this only works for floats. And this is the type of object that you are putting in there. So S, you can be putting in a string. D, you're putting in an integer. F, you're putting in a float. And E, you're putting in exponential. Now, if we were to actually run this line of code, so 0:6.3f dot format with this long string of pi there, we would see it's got 6 characters, but the first character is a space. So we have space 3.142. And that space happens because we've told it to have 6 characters, but we only told it to round to 3 here. So we have 3 decimals, so it only makes up for 5 characters between the 3.142, so it had to add an extra space there. Now you can add additional formatting stuff there. You can right align it so that it's lined up on the right and any additional spaces go on the left. You can left align it so any additional spaces go on the right and it's flushed to the left. You can center it so it's right in the middle and all the spaces are evenly spaced. You can 0 pad it. So if you put a 0 here, a 0 would actually end up in front of this 3. You can put a space there, and that'll put a space in front of positive numbers and a negative sign in front of negative numbers. Or you can put a plus sign, which puts a positive sign in front of positive numbers and a negative sign in front of negative numbers. Now, string formatting is particularly helpful in for loops. For example, we have our file names from our first video in this lesson, and you can see that it has the float number and the profile number, and it's printed out in all of these different ones. And it can get really tedious to write all of them. And if we want to get different profiles, we'd have to write new ones. And that can get really hard to do. Instead, a better way of doing that is to say file names equals a blank list. And then we're going to go through a for loop, creating a float string for each of the different file names. So our float string is equal to our float number, D5901105. Notice that that doesn't change between the different variables. And then we're going to put in our custom bit right here for our profile number. So we're going to put in whatever is in our format function, and then we're going to say pad it with zeros, have 3 digits, and have it as an integer. So when we do that, we get these as our file names, which is great. It's the same as this list. But the really cool thing about this is that now if we wanted to get different profiles, we could get the first profile, second profile, all the way up to 6th profile by just changing these numbers, range 1 through 7, instead of having to go through and change a whole bunch more numbers in order to get those. String formatting can also be really helpful in functions, where if we're trying to read our profile, we create our profile name and we say, oh, we're going to say D, and here is our float number, right? So the 0 argument, and we're going to input this variable, and we're going to give it an integer, and then we have an underscore, and then we're going to have another placeholder in the 1 argument, so the profile number, and once again, we're going to have that padded 3 integer. And we're going to print it out, and then we're going to open that data set with our file path and our profile string, right, because that is our file name, and then we're going to squeeze it, and we're going to return our data. So if we run that with our file path from our video 1 from this lesson, and we run that function of read profile with our float number, 5901105, our profile number, number 186, and our file path, where to find that file, we can read that data with just this 1 line of code, and we can pick exactly which float number, so we can choose any float number of the thousands that Argo has deployed, and we can pick any one of the profile numbers of that float. The next thing I want to talk is how to add math symbols to strings on figures. And a lot of times when you're plotting, you're going to end up needing to use a subscript or a superscript, or you're going to have to use a Greek letter. And there's a really easy way to include those things on your plots. So here you can see a plot of my sine and my cosine. You can see my theta here, and it's actually the Greek letter theta. And I've labeled these vertical lines at 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. And in order to do those pi's and to do that theta, you use a $sign, backslash, and then the name of whatever Greek letter you're using. So in this case, pi, in this case, theta. And you can see this in the code that I wrote for it here, where we have the sine of theta as our legend here, cosine theta for a legend there, and for our X label, and for our line labels there. Now, that's just a couple of examples, but really the format is just a $sign, insert the character there, and then end with a $sign. So if you want to do a superscript, you do $sign, whatever you want on the base, caret, whatever you want on the top. Subscripts, you just do an underscore. And then for special characters, you have to use the backslash and then the name of whatever that thing is. So here are a few very common ones. There's a whole list of them in this website here. And you can see that there's, a lot of different Greek letters, a lot of special symbols, and whatever you need to write into your plot will work for that. That's all we have for today. And this is actually the last video of the quarter. So we will see you guys on Tuesday, and have a good day.